Then go over to our PowerPoint. All right, and you know, since I'm on the laptop, if you guys can't hear anything or anything, just let me know while we're doing that. Okay, so transmission basics, transmission techniques in use on today's networks are complex and varies. In this section, they're going to cover measurements that indicate network efficiency and obstacles to good network performance. So the three big ones are frequency, bandwidth, and throughput. Those are the ones you're going to hear a lot. So frequency is typically measured in megahertz or gigahertz. Usually now it's if you're dealing with networking cables and stuff, a lot of it's is gigahertz just because of the speed that we see. But you know, you might get some megahertz on some of the smaller networks. That indicates the number of times in a second that an electrical signal can change states. Bandwidth is the amount of data that could be theoretically transmitted during a given period of time. And throughput is the measure of how much data is actually transmitted during given time periods. Okay, so new technologies such as modulation, that's sending the data over an analog signal, and encoding, that's converting data into digital signal for transmission, offer methods for increasing theoretical bandwidth and effective data throughput given the same maximum frequency. So they've always worked for years to see how much more you can get out of similar or old transmission methods with, you know, new tweaks. So don't be surprised if you see new stuff in there. Okay, transmission flaws. Noise is any undesirable influence degrading or distorting your signal. So noise is measured in decibels. Remember that, which most of the time you can remember that just, you know, noise decibels, because that's how they do music and things like that too anyway. So two common sources of noise include the following: EMI, or electromagnetic interferences, which can be caused by motors, power lines, televisions, copiers, fluorescent lights, etc. One type of EMI is RFI, or radio frequency interference. And then there is grumpy cat here, crosstalk, which occurs when the signal on one wire infringes on adjacent wire signaling, which is also why a lot of times you have cables that are shielded. Alien crosstalk occurs between two cables. Near end or next, near end crosstalk or next occurs near source. Far end crosstalk, I usually just say far end, I forget the rest of that. FEXT occurs at the far end. Attenuation is, I'm probably going to have you share that in just a second. Attenuation is the loss of signal strength as it travels away from the source. Remember that, as it travels away from the transmission source. Signals can be boosted using a repeater, which regenerates a digital signal in its original form without the noise previously accumulated. Latency is the delay between signal transmission and the receipt. So latency may cause network transmission errors. The length of cable affects latency, as does the existence of any intervening device. So when they were talking about that RTT, that's round trip time, that's how, as the time for packet to go from sender to receiver, then back from receiver to sender. And that's also how they check for, they can see if there's latency issues based on your RTT. If packet experiences varying amount of delay, they can arrive out of order, a problem commonly called jitter or packet delay variation. Duplex, half duplex, and simplex. So a NIC has settings that include the direction in which signals travel over the media and the number of signals that can traverse the media at any given time. These two settings are combined to create different methods of communication. So there's full duplex, that signals travel in both directions over a medium simultaneously. Half duplex, signals may travel in both directions, but only in one direction at a time. And simplex, signals may travel in only one direction, and it is sometimes called one-way or unidirectional communication. In Windows, use Device Manager to configure your NIC, and you can include your speed and duplex settings in there if you want to do it that way. Stephen, were you talking about a freeway metaphor? Were they talking about like the interference, or were they talking the duplex, half-flex, simplex?
They were just talking about like a freeway metaphor for the bandwidth, the throughput, frequency, all that, not for what you're on right now.
Okay. For some reason, I thought they were going to include that in there. Do you remember what it was for the transmission?
So I'm looking at it right now, and basically
go ahead,
bandwidth is the size of, or I can share the page if you want, but you want me to share the screen?
Yeah, let me hold on one second. I have to allow multiple. Okay. Oh my goodness. I promise I'm not abusing her. She just yells no matter what I do. Okay, go ahead.
Screen share. All right, so basically, yeah, your bandwidth is the size of the freeway, or like the number of lanes. The frequency is how often it lets things through. The throughput is what makes it through, stuff like that. It's pretty simple.
Well, that's a good figure there. Yeah, and that's one that you might want to screen capture, that because that is a good way of explaining the difference between them. I haven't before the text on this one, I haven't seen that particular graphic either. So so yeah, that's a really good one to do. For some reason, I was also thinking of what's another good one? There was one on the one that we're going through, the next section here. If you think of, since we're talking about traffic, it's kind of the same thing, but it's more about the directions of traffic. So the simplex, think about your one direction, your one-way streets. And your half duplex, they may go in both directions, but you think about it like they've got a traffic light and only you can go one direction, but they have to switch, like, okay, if I go this direction, this side's got a red light for going. And if I go this way, this side's got a red light for going. Does that make sense? And full duplex is just absolute pandemonium. Anyone can go everywhere. So
in other words, full duplex is like driving in India.
Pretty much, yeah. If you've ever seen some of those videos where they have absolutely no signal lights and no lanes paved out, and they just kind of go bonkers. Yeah, the signal can go either way. I mean, in order to do that, it does have to have a good equipment and things like that to do that. But that is a good analogy as far as traffic is going. Okay, and this is just a section here showing you in your device manager under your advanced, where you can go in and change your speed and duplex like it was talking about. I personally don't mess with this unless you know that you absolutely have to have those changes. But sometimes if you're doing special things with your routers, or as you mess with stuff, as you learn more about technology, sometimes you're like, hey, this would work better this way. And then as you change it, you can do things like that. Okay, multiplexing. Multiplexing is a form of transmission that allows your multiple signals, like we were talking about, simultaneously over one medium. Can do multiple signals. The medium's channel is logically separated into multiple smaller channels or sub-channels. Multiplexer, MUX, is a device that combines many channel signals. It is required at the transmitting end of the channel, and a demultiplexer or DMUX separates the combined signals on the receiving end, which is how you're able to just create absolute pandemonium. during the traveling, because you have one at the beginning and one at the end that just kind of take everything apart on the other side and say this stuff goes here. 3 types of multiplexing that are used on copper lines are time division multiplexing. This divides a channel into multiple time intervals. STDM, which is statistical time division multiplexing, assigns slots to nodes according to priority and need. Or FDM, which is frequency division multiplexing, assigns a different frequency band for each communications subchannel. So when you do the frequency division multiplexing, the types of them don't overlap because each one has its own frequency in which to transmit. And there are 3 types for fiber optics. There's WDM, which is wavelength division multiplexing, which carries multiple light signals simultaneously by dividing a light beam into different colors. DWDM, which is dense wavelength division multiplexing, which increases the number of channels provided by normal WDM. And then there's CWM, which is coarse wavelength division multiplexing, which lowers cost by spacing frequency bands wider apart to allow for cheaper transceiver equipment. Okay, coaxial cable and, sorry, my bars here, twin axial cable. So coax cable was the foundation of your Ethernet networks in the 1980s. Coax has been replaced by newer media types. It's a form of coax is still used for cable internet, cable TV, and some multimedia connection types. Coax has a central metal core surrounded by an insulator, a braided metal shielding, and an outer cover called the sheath or jacket. The 2 types are RG6 and RG59, and they can terminate with one of 2 connector types, your F connector or your BNC connector. Okay, and then twin axial looks similar to coax, except there are 2 cores. The 2 cores cooperate in a half duplex fashion to transmit your data. This makes it capable of supporting higher throughput than coax. It's made from 26 or 28 AWG copper, so it's resistant to damage from rough handling. And the type of twin ax cable determines the maximum supported distance. So passive is sufficient for the shortest distance of less than about 5 to 7 meters. And active contains internal electrical components to strengthen the signal of up to 10 meters. And here are some twin ax cable information. So twin ax cable factory terminated with transceivers. Each core pair is welded to a circuit board inside the transceiver, and you can see how that is. Okay, next there are twisted pair cables. Twisted pair consists of color-coded insulated copper wire pairs with 0.4 to 0.8 millimeter diameter. Every 2 wires are twisted together to form pairs encased in plastic sheath. Twisted pair cabling in Ethernet networks contain 4 wire pairs. Fast Ethernet uses 1 pair to send data and 1 pair to receive data. Networks using gigabit Ethernet use all 4 pairs for both sending and receiving. Most common twisted pair types include, and then there's your CAT 3.5, 5E, 6, 6A, 7, 7A, and 8. CAT 5E or higher is used in modern LANs. Most of the places that I've seen are at least up to a 6, but I've seen some that are still on 5. So you never know quite where you're going to run. All twisted pair cable falls into one of 2 classifications: shielded twisted pair or unshielded twisted pair. Shielded twisted pair. So wires in STP cable are individually insulated and may also be surrounded by metallic substance shielding foil. Shielding acts as a barrier to external electromagnetic forces. The shielding must be grounded to enhance its protective effects. Effectiveness of STP's shield depends on the following: level and type of environmental noise, thickness and material used for the shield, what kind of grounding mechanism, symmetry, and consistency of the shielding. So newer types of cable like Cat 8 incorporated a more sophisticated shielding type of shielding material, more tightly twisted wires, higher bandwidths to offer data rates rivaling fiber optic cable at short distances. And here is an example of what a shielded twisted pair cable looks like. So you have your jacket sheath, your braided copper shielding, your foil shielding, and then your twisted pairs inside of that. And then a picture of what that looks like inside of a Cat 8 tape cable. Yeah, they definitely do look shielded to the max. A lot of the times you see the more shielded ones, you'll see in areas, I've seen them in places that they're forced to upgrade to those if you're really close to places like power switching stations, or areas like that, because there are some areas that are just naturally occurring, have higher things like electromagnetic interference, any place with a high data security. Usually the networking stuff will get upgraded faster depending on A, your budget, and B, the amount, the type of data and the amount of data you move. So you'll see that more as you go along and get out in the world and see more of that as you work with it. Untwisted shield or unshielded twisted pair, UTP cabling consists of one or more insulated wire pair encased in plastic sheath, does not contain additional shielding. This makes UTP less expensive and less resistant to noise than STP. So it's one of those cheaper but situations. So historically, UTP was more popular than STP. Modern cable prices have dropped low enough that STP prices are becoming more reasonable. That's because no one's using it. Comparing to STP and UTP. So STP and UTP similarities and difference include the following. Throughput, STP and UTP can transmit at the same rates. Cost, as STP is more expensive than UTP. Connectors, STP and UTP use RJ45 jacks. Noise immunity, STP is of course more noise resistant. Size and scalability, the maximum segment length for both is 100 meters on Ethernet networks that support data rates from 1 Mbps to 10 Gbps. Some categories of STP require shorter segment lengths to achieve maximum throughput. So just remember 100 meters, and then just remember that STP sometimes requires shorter length for max throughput. Cable pinouts. Okay, so proper cable terminations required for the two nodes on a network to communicate. Poor termination can lead to loss or to signal loss or noise. TIA-EIA specifies two methods for RJ5 plugs. There's the A and B, and remember there's no functional difference between them. B is the more common of the two that you'll see out there. There's no function. So let's see. We remember those videos I had you guys watch where we were talking about the two different ones, and they kept showing you little cards with the pinouts, and they kept saying, here's B, here's B, here's B. There are some places that require A, and it's just about a slight switch in where you move the colored. I think it's the green and green stripe or the orange and orange stripe. I'd have to look, but I think that's which ones are changed. And we'll get to see right here. Okay, so top is A, bottom is B, and it's the orange and green. I was right, that are different between the two. So just, I don't know that I haven't seen any that says what's different, but you never know. There might be some sort of question out there that's like, which color is it? That's so just remember orange and green are the two that they mess with when they change those around.
Don't they make literally no difference as long as the cable or the pairs on both ends match out?
Exactly. As long as you use and one is type A and end two is type A, as long as they're, as long as things match up, you should be okay.
Well, like what I was saying, like you could, the reason they twist them is because that way, I don't remember the reasoning it's stated in the reading. But like you could literally have it where it's just whatever color white pair, and then keep going down all 4 sets as long as it matches up on both sides, because it's just that the data can't get basically both end pieces have to match, right?
I believe it is that both end pieces have to match, but as far as it goes for cabling standards, they want you to use either one or the other within whatever facilities that you're using. So yeah, but yeah, I do believe you are correct. And if you ever want to mess around with it, that's a good way to be like, does this work? No. Does this work? That's the best way to find out on a lot of those. PoE, power over internet. This is more and more popular, especially in areas where they use security cameras. So it's an 802-3AF standard that specifies a method for supplying electrical power over twisted pair Ethernet connections. The amount of power provided is 15 point, stop trying to fight with the other cats. Is 15.4 watts for a standard PoE device and 25.5 watts for newer devices. So knowing whether it's an AF or an AT standard will also tell you, like if you're purchasing cameras or anything like that, it'll let you know which type you need. That's one of those ones that you're going to need to know how to look up. I don't believe that there are any questions on that. Not on any of the ones that I wrote, but you might, if you happen to remember that off the top of your head, great, but I can guarantee that's something that I would have to look up. Just be aware that there are 2 standards that you need to know the difference between so that you can look them up if you need to do something in the future. PoE standard specifies 2 types of devices: your power sourcing equipment and powered devices. And it requires 5 or better copper cable for Cat 5 or better. The PSE device first determines whether a node is PoE capable before attempting to supply it with power. On networks that demand PoE but don't have PoE capable equipment, you can add PoE adapters. Okay, so this is just an example of, you'll see your splitter with your power and a PoE switch, non-PoE switch, and you can see the difference there. So that just shows that you have a difference between your data and your power. This one needs to have the adapter, this one doesn't. Okay, Ethernet standards for twisted pair cable. Cables category, Cat 5e 6, determines the fastest network speed it can support, and that's in layer 1. The device's NIC is also rated for maximum network speeds. Most LANs today use devices and NICs that can support fast Ethernet and gigabit Ethernet. Devices can auto-negotiate for the fastest standard they have in common. The fastest Ethernet standard currently is 100 G-base-T, and the 2 new standards recently ratified were 2.5 and 5. The new standards provide intermediate steps between 10 and 100. but just remember that you have, they can auto negotiate, but what they're going to do is they're going to look at the maximum, whatever it is that can be the fastest. But then you have to remember it's going to look at the fastest, but it's going to look at the lowest fastest. That's going to sound weird, but if you have a bunch of devices and they're all in a line and just one of them is lower than the other ones, if they have to use that one, it's going to use the lower one of the rest of them. Does that make sense? Yes, the lowest of the fastest. Yes. That sounds weird, but it's faster internet, but it doesn't matter how fast it can go. It's one of those the weakest link in the chain type things. That's the one that's going to set your speed to. So make sure that if you want good speeds all the way across, that everything in the line, including the cabling, can support whatever speed it is you want. Yeah, I see that a lot too. They're like, okay, we can go super fast. And it's like, that's great, but your cabling can't. So you never know. Okay, so knowledge check. What is the typical maximum segment length for Ethernet networks? A, B, C, D. So 10, 100, 1,000, 10,000. For satellite systems, maybe. Looks like everyone's BBBB. Good job. Yeah, they've repeated that one over and over and over again. So I'm glad you guys got that. All right, next, fiber optic cable. And I will tell you, if you ever get the chance to on-job train with how to work with fiber optic cable tools, it is considered it's not really a niche, but there are more people that are trained in copper wiring than there are in fiber, because fiber optic cable and tools are more pricey than the copper. So if they ever are like, yeah, we'll train you how to do that, take it. You never know how that can help you. Yeah, and if you, that's exactly it. If you have the capabilities and the knowledge, and it's always something good to fall back on, because fiber optic is blowing up. So if you get the chance to train for free and you ever decide, hey, I want to go do that, you can make quite a bit of money. So fiber optic cable or fiber contains your glass or plastic fibers at the center or the core. Data is transmitted via a pulsing light sent from laser or light emitting diodes, LED, through central fibers. Surrounding the fibers is a layer of glass or plastic called cladding. The cladding is less dense than the glass or plastic in the strands, and so reflects light back to the core in patterns. This reflection allows the fiber to bend. Outside the cladding, a plastic buffer protects the cladding and core. The buffer is opaque and it absorbs any sort of escaping light. It's surrounded by Kevlar or polymeric fiber strands. Okay, so this is an example of fiber optic cabling, and the heads on it look significantly different too, so hopefully it'll show us that too. So as you can see, there's your inside, and then as you can see, it's kind of twisted around, and then it goes out in the way that it was talking about. Yeah, if you mess with there's basically, if it's the glass or the inside, there's like a little cutter that I have a guy that I used to work with that used to do fiber optic cabling and regular cabling, and he said that it was really easy to mess that up by messing up the cutter within the whatever it was that cut the fiber optic cabling. Because if you didn't cut it right, you could cause all sorts of problems, and it sounds like you really have to know your tools well on that one. So fiber optic cabling offers the following over copper cabling. It's got extremely high throughput, very high noise resistance, excellent security. It's able to carry signals for longer distances. Drawback, it's more expensive than twisted pair cabling, and it requires special equipment to splice, like I was talking about. Yeah, they look almost like if you've ever seen anything having to do with jewelry tools, a lot of their stuff looks very similar to some of the things you use for jewelry work. Sorry, my cats are apparently putting on a show this evening. They've been racing around. I think they've all got spring fever. Okay. Next, MMF or multi-mode fiber. This contains a core with a large diameter, larger than the single mode ones, and it's 50 to 62.5 microns. It's laser or LED generated light pulses that travel at different angles through MMF. Signals travel over MMF experience greater attenuation than single mode fiber. Common uses are cables connecting routers, switches, servers on your backbone of a network, and cables that connect a desktop to the network. Transition between SMF and MMF might occur at an FDP, like a fiber distribution panel. MMF connectors can be classified by the number of fibers they connect. SMF connectors are classified by the size and shape of the ferrule. The ferrule is the extended tip of a connector that makes contact with the receptacle in the jack. Shapes and polishes used by SMF ferrules are to reduce back reflection include the following: ultra polished and angle polished. SMF connectors are typically available with a 1.25 millimeter ferrule or a 2.5, which is just, double ferrule. The most common is the 1.25 connector is the LC or local connector. 2.5 mm connectors are the SC, the standard connection, and the ST or the straight tip. Most common MMF connector is the MTRJ or mechanical transfer register jack. I do not expect you to remember all of these just boom off the top of your head. This is one of those ones that you're going to have to flashcard to remember, or at least know how to look them up, because it's just a lot of terms. So unless you're specifically going into cabling, and this is stuff you do every single day, this is one that you should just know how to be aware of and how to look up. Okay, media converters. A media converter is a hardware that enables networks or segments running on different media to interconnect and exchange signals. The media converter completes the physical connection and converts electrical signals from copper cable to light wave signals. You can also be used to convert networks using MMF with networks using SMF. Fiber transceivers. Some switches allow you to change and upgrade its interface. They contain sockets where one of the many types of modular interfaces called transceivers can be plugged in. The GBIC, pronounced GBIC, was a standard type of transceiver designed for gigabit Ethernet connections. Newer transceivers that have made the GBIC obsolete include SFP, or small form factor pluggable, XFP, 10 gigabit small form factor pluggable, SFP plus, QSFP, or quad small form factor pluggable, QSFP plus, and CFP, which is Centrum form factor pluggable. To avoid using the incorrect transceiver, you have to pair these devices based on supported speed and protocols. So installing a transceiver can be achieved by sliding the transceiver into a socket on the back of the connectivity device. And most transceivers come with a tab or latch system and are keyed so that they will slide into the socket when aligned properly. Ethernet standards for fiber optic cable. This is one of those ones that you can write down if you want to, if you really want to remember everything. But there's 100 base SX, 100 base FX, 1000 base SX, 1000 base LX, 10G base SR, 10G base LR, and then it goes through and tells you the different wavelengths and things like that. Common fiber cable problems. Fiber type mismatch is actually more of a fiber core mismatch. Even same mode cables can be mismatched if the cores have different widths. Wavelength mismatch occurs when transmissions are optimized for one type of cable, but sent over a different type of cable. Dirty connectors. If fiber connectors get dirty, signal loss and other errors can start to cause problems. It's basically like if you think of a glass window and then you have stuff that gets all over it. It's kind of the same thing. It's difficult to see through, difficult, when things get dirty, they have to fix them, or sometimes they have to cut the thing off and put new heads on it and things like that to fix them. I'm not for sure about that one. Guessing yes. Yeah, I was going to say, I'm guessing that because they're two different cores, that one would not, that they would not mix. I do know that none of the ones that we used, they did not mix glass with plastic cores. So I'm assuming that's why. Link loss. The power of a light signal emitted at one end of the connection is subjected to many losses along its way to the other end. These include losses from distance, losses from multiplexing, losses from imperfected connections, patches, or splices. And if those are not done well, if the tool's messed up, if the cable's messed up, there's all sorts of things that you can have problems with. Or breaks. I have seen, usually the problems that I've seen with, at least when you're switching from the copper over to fiber, people are used to beating the crap out of the copper cables, and you can't treat the other ones quite the same way. A lot of the times it's, I slammed such and such cable in the door and suddenly now it's not working. It's like, well, that's because it's made of glass on the inside, and if you slam it in the door hard enough several times, of course it's not going to work. I've seen all sorts of things. It's usually due to someone stood on it, trumped it, did basically general cable abuse. Yeah. User error. Yeah, exactly. Cable troubleshooting tools. Now, we've seen some of these in some of the videos that I showed you, but that was for other things. You can start troubleshooting network connection problems by checking the network connection LED status indicator lights. Steady light indicates connectivity. Blinking light indicates activity. Red or amber light might indicate a problem. If a cable issue is suspected, you need to know which tools are designed to analyze and isolate problems. There is a toner or a tone generator. That's a small electronic device that issues a signal on a wire pair, and a tone locator or a probe. And that's a device that emits a tone when electrical activity is detected. A probe kit or toner probe is a generator and locator combination, and it's sold as a set. Tone generators and tone locators are used to determine where wire pair terminates. They cannot be used to determine cable characteristics, but they can at least, this has been used for a long time, and originally was created by electricians. They tone out electrical lines. They'll start out at your electrical box and be like, they'll trace it down and be like, okay, at a plug, or, you know, that's how they test whether or not the wires are getting the electrical where it's supposed to go. And it's basically the same thing for network cables. It'll tell you this is where it starts, this is where it ends, but it won't tell you anything about the cable characteristics themselves. Yeah, kind of like a multimeter. Yeah. But this one's, they're slightly different. I'll have to look for a video that shows you how to use just one of those. Because they showed when we did those ones where they were showing how to put the new head on there, they had one and he pulled off the mobile part of it just to show you how to use the non-mobile part. So they're frequently I think I found one that was like $10-15. So they don't have to be super expensive. They do make ones that have this function, but then they also have tons of other more expensive functions. Those are those $500-600 ones that'll tell you all sorts of stuff though. Okay, multimeters. Those measure your electric circuit characteristics like resistance, voltage, and impedance. To use a multimeter, measure your voltage to verify the cable is conducting, check for the presence of noise, test for a short or open circuits in the wire. A short circuit is an unwanted connection. Open circuit is one where needed connectors are missing. Cable continuity testers or cable testers, where the cable carries a signal to the destination. Copper-based cable tester. Oh, see, now I think I was mixing some of these up. My bad. Yeah, I was thinking of, yeah, this one's slightly different. I'm sorry, I was thinking of the other one, but this one is just basically you probe for you use the tone to tone and probe to figure out where the signal is going. The continuity tester is the one I was for some reason was thinking of. That's the copper-based one. Does unit generates voltage, as the remote unit detects the voltage. Most of them provide a series of light and sometimes an audible tone. They're basically a pass-fail. Some testers verify UTP, STP wires are paired correctly, not reversed, crossed, or split. Fiber optic continuity testers, those issue light pulses on the fiber and determine whether the pulses reach the other end. So this is another one of those. It's going to be more expensive than some of the other tools because it's slightly more specialized. Most of them are portable, lightweight, and inexpensive. It's when they start combining multiple features that you'll see the ones that are more expensive. Okay, performance testers. Line tester or certifier performs similarly to continuity testers, but can be used to measure distance to a connectivity device, termination point, or a cable fault. They measure attenuation, they measure near-end crosstalk, measure termination resistance and impedance, issue pass-fail ratings for your different standards, store and print results, or save to a computer database, and graphically depict attenuation and crosstalk. So these are going to be more expensive. TDR domain reflectometer issues a signal, then measures the way the signal bounces back to the TDR, and that indicates distance between the nodes, and it indicates whether terminators are properly installed and functional. OTDRs, or optical time domain reflectometers, those measure your fiber length. OTDRs also determine faulty splice locations, breaks, connectors, bends, and measure attenuation over cable. Do you remember us talking about regular network cables? They were talking about there's only so much you should really bend them. It's kind of the same way with fiber cables too. They can measure attenuation over the cable, and OTDRs can be a lot more expensive. OPM, or optical power meters, they're also called a light meter, measures the amount of light power transmitted on a fiber optic line. An OPM must be calibrated precisely, following highly accurate optical powered standards. The surrounding room temperature, connection type, and the skill of the technician all affect the final test results. Yeah, OPM and OTDs usually are more expensive, especially the OPMs usually are more expensive because they require special training to run them.
So when it's saying the OPM meter, is it saying that you can actually run power over a fiber line?
Yeah, you can. They have PoE for those as well.
Interesting.
Mm-hmm. So, which tool would you use to test a twisted pair cables pinout? A, B, C, or D, OTDR, toner probe, OPM, or continuity tester? No, looks like everyone had pretty much the same idea. So either you saw me flip over and you saw the answer, or you were actually paying attention. So good job. Okay. So what we went through was basic data transmission concepts, frequency, bandwidth, throughput, multiplexing, common transmission flaws, and then a bunch of stuff on our twisted pair, twin axial, coaxial, fiber optic, and different connectors, and all sorts of cable issues. So does anybody have any questions on this material, on anything having to do with cables? If I don't know it, I can at least find someone to answer the question. So questions, comments?
So on a scale of 1 to 10, how important is it that we know the difference between a copper cable and a fiber?
I think that you would know the difference if you looked inside of it. Don't you think?
No, I mean, sure.
Do you
I don't know.
like,
I can't really. No, I was joking. I can't really figure out a way to continue the joke. So
okay. I was going to say, I should hope that you would know that there is a difference between it. But as far as knowing all the standards, though, the biggest problem with when it comes to cabling is there are so many standards and things. So and also remember muscle relaxants, so it takes me a while to get a joke right now. Don't worry about it. Yeah, step on it. If it breaks, it's fiber. Yeah, don't test that way. Or if you do, don't tell them I told you to test that way. But yeah, just remember, even the professionals that do cabling, usually they only get super specific about their own particular area. Like the fiber optic cable layers, they will know the fiber optic stuff really, really, really well, but they may not know the other stuff. It has a tendency to, you memorize the things that you use constantly. So just be aware that there are standards and that you can go out and look them up. And that just also be aware of the different throughput types, the different materials it's made through of, and things like that. So it really depends on what end of security. I know you're kind of beginning on this, but if there are different areas of security where you might have to do more with the physical aspect of keeping cablings secure, or you might go into policy writing, in which case you might have to know where to find all of the standards to include in your policies. So no, if you can manage to be a fiber tech and you want to be a fiber optics tech, they do get paid bank, but you're going to spend a lot of time crawling around and ducts and walking through drop ceilings, and they do a lot of that. So just be aware of that. I would highly suggest that if you've never pulled cable and you get the option to do a follow along with someone that pulls cable before you decide if you want to do that, do it. So I know a lot of people that were like, wow, I really didn't want to do this, but I already switched over into it and for whatever job. And if you can go and try out for a day as many different IT jobs as you can, do it. That's my suggestion. Okay, so no specific questions. Okay.